Hello, good morning everyone. Today I would like to show you how to find the inverse Laplace transform using the linearity property. First of all, let me show you one of the examples. Okay. Inverse Laplace transform of 10 over s power 4 plus 1 over s power 5. Okay, we can solve this problem separately. Okay, so we know that this part s power of 4 is from table of Laplace transform, which is t power of n equivalent to n factorial s power of n plus 1. So if we have s power of 4 means that is the n is 3. So 3 factorial over s power of 4, which is we obtain from this formula. Okay, so this is in the Laplace transform. And since we have 3 factorial and in the original question we only have 10, so we take out the 10 and divide by 3 factorial. If we cancel out the 3 factorial and 3 factorial, we still obtain the same value, which is 10 power of s power 4. Okay, and same to the next one. If we have s power of 5, means that it is a 4 factorial over s power of 5. Okay, and 4 factorial is not our original from the question, so we need to divide with the 4 factorial. Okay, now we have 10 over 3 factorial means that 3 times 2 times 1, so we have 6. And 3 factorial or inverse Laplace transform of 3 factorial over s power 4, we obtain t power of 3, and then plus with 4 factorial. So 4 factorial is 4 times 3 times 2 times 1, so we have 24. And then the inverse Laplace transform of 4 factorial divided by s power of 5 is we obtain t power of 4. So we can solve this one. Okay, this is the answer. Okay, apart from this, I can share with you another example, which is inverse Laplace transform of 2s plus 3 over 3s squared plus 4. Okay, if you look at the question here, 3s squared. Usually in the table of Laplace transform, we don't have any 3s or any constant s. We only have a single s or s squared. Okay, therefore we need to divide with 3. Okay, we need to divide with 3. So we left inverse Laplace transform. This is we separate into 2 parts. 3s squared divided by 4. Okay, since this is the plus, so we divide into 2 parts. Okay, now we divide with 3. So each one we divide with 3, so we have 2s over 3 over 3s squared over 3 plus 4 over 3. And then this one also the same. We have a 3s squared. We don't want the 3s squared. We only want the s squared only. So 3 over 3. And then 3s squared over 3 plus 4 over 3. Okay, now this one is cancelled out. Okay, we have 3 over 2 as a constant, so we take out the 2 over 3. and then inverse Laplace transform, and now we left the s over s squared plus 4 over 3. And then similar to the other side, this one cancel out, this also cancel out, so we left 1 s squared plus 4 over 3. Okay, so can you guess what is this? If you check from the table of Laplace transform, this one we can get it. We can get a cos. Okay, because the cos at is equivalent to s over s squared plus a squared. So we have the same format. So we change it again to a cos format. So cos format is s over s squared plus a squared. So we need to square root and square. Okay. This one is 1 over s squared plus 4 over 3. This one we can change to the sign, but take note that the sign at is equivalent to a over s squared plus a squared. Okay, now if this is referred to the a squared, we need the a here. So therefore, we change to s squared plus 4 over 3 square root and square. So this one will be 4 over 3. Since this is square root 4 over 3, and if we want to remain the value of 1 here, we need to divide with the square root of 4 over 3. Okay. So now we have this one, we can change to cos, because cos at equal to s over s squared plus a squared. So we can change to cos 2 over square root of 3t plus. Okay, this one, 1 over square root of 4 over 3, we obtain square root of 3 divided by 2, because square root of 4, we obtain 2, and then this one we obtain sine 2 over square root of 3t. That's it. Now, if you have looked at the linearity property, let's look at how we solve the inverse Laplace transform using the first shift theorems. Okay, so we look at example for the first shift theorems of inverse Laplace transform. Okay, now let's look at the example. Inverse Laplace transform of 3 over 2 s minus 4 squared. Okay, how are we going to solve this kind of question? Okay, if you look at here, this one is a constant, so we can take it out. Okay, for easiness, you can take it out. Take out the constant, and we left 1 over s minus 4 squared. Okay, what else we can do? What else we can do? Okay, s minus 4. If you look at s minus 4, it's a shifting. So we can change using the table of Laplace transform. Exponent at equal to s minus a. Okay, we can use this one. So again, 3 over 2 s minus 4. We can change to exponent 4t. We change to exponent 4t for this part. And then we still left 1 over s squared. Okay, what we can do for inverse Laplace transform of 1 over s squared. Okay, don't forget we have t power of n equal to n factorial s m plus 1. So now in this case, the n is 1. Okay, n is 1. So your answer will be t. Okay. After this example, let's look at another example again. The inverse Laplace transform of 3 over s plus 4 power of 4. Okay, how are we going to solve? If you look at this question here, again, s plus 4. S plus 4 is a shift. So we can take out the shifting. Okay. So s plus 4 is equal to exponent negative 4t. And then we left 3 over s power 4. Okay. As you know, this one is from the t power of n. So we have exponent negative 4t inverse Laplace transform. Okay, for this part, t power of n, if you have n power of 4, means that is 3 factorial. So it's 3 factorial divided by s power 4. It's totally different from, so s over s power 4 is totally different from 3 factorial s power 4. Bear in mind, because 3 factorial here means that 3 times 2 times 1. The value is totally different from the 3. So that's why we take out the 3 divided by 3 factorial. Okay, if we write in this way and the value is still remain like this. So that's why we divide with, that's why we have a 3 over 3 factorial. Okay, and after this, you have, you simplify it. So this one you get 6. And then 3 factorial, you get t power of 3. Okay, and you simplify, you get t power of 3 exponent negative 4t over 2. Hope you can understand. Okay, we look at another example again. Hopefully can make you more understand on how to use the first shift theorem in the inverse Laplace transform. Okay, if inverse Laplace transform 12s divided by s minus 1 power 4. Okay, if you look at this question, roughly what can you inverse? You can have 12s. If based on table transform, it seems like none of them. Okay, so what should we do? Okay, since we have the denominator, we have s minus 1. So our inverse Laplace transform, I write it here. So equivalent to inverse Laplace transform of 12 s minus 1, because we have a s minus 1 here, and then plus with 12 s minus 1 power 4. Maybe you don't understand why I need to multiply with the 12 multiplied with s minus 1 plus 12. This is because, okay, if you want to use the first shift theorems, we need to do like this. Okay, so here we will result in 12s minus 12 plus 12. Actually, we still remain the, if this one can cancel out, we remain the value of 12s. Okay, how we choose the s minus 1 is because from the denominator. Now we can separate into 2. Since we have the plus here, we separate into 2. Okay, so you have inverse Laplace transform 12 s minus 1 divided by s minus 1 power 4 plus inverse Laplace transform of this part 12 divided by s minus 1 power 4. Okay, now 12 is a constant. We take out the constant so that easy to solve the question. So we have s minus 1 power of 4 plus also constant, so 12 1 over s minus 1 power of 4. Okay, if we look at this one, actually we can s minus 1 divided by s minus 1 power of 4 is the same. So actually we can cancel out this one and this one, so we left 3. So 12 inverse Laplace transform 1 over s minus 1 power of 3 plus 12. Okay, this one is a shifting. So we change to exponent t and then we left inverse Laplace transform of 1 over s power 4. So s minus 1 here is a shifting property again. So we change to exponent t inverse Laplace and we left 1 over s power 3 plus 12 exponent t. Okay, if we have s power of 4 means that is n equal to 3. It's a 3 factorial. So since we have 3 factorial, we need to divide with 1 over 3 factorial and then inverse Laplace transform 3 factorial divided by s power 4. Okay, so now we have 12 exponent t, and then this one again, the n is equal to 2, so we derive with 2 factorial inverse Laplace transform 2 factorial over s power 3 plus, okay, 3 factorial we obtain 6. So 12 exponent t divided by 6, and this is t power 3. So now we have 6. This one is 2, and this is 6. So 6 exponent t, and then again this one we obtain 2 t power of 2, and then plus 2 exponent t t power of 3. We simplify it, so we have this one, we have same value, so we factorize it. 6 t power of 2 plus 2 t power of 3, and then multiply with exponent t. Okay, again I'll show you another example on the first shift theorems of inverse Laplace transform. Hope to increase your understanding. Okay, we have this question 1 over 3 s divided by s power of s plus 3 power of 2 plus 2. Okay, we can similarly like previous question. Okay, we cannot directly solve, and we need to use the first shift theorems. That's why we change to 1 over 3 multiplied with s plus 3. So this one, we change it to 1 over 3. We follow this one, s plus 3. And then if you look at this one, 1 over s plus 3 minus 1, what we get? 1 over 3s plus 1 minus 1. So that's why we minus 1 here. Okay? Because we still get the same value as this one. So divide by s plus 3 squared plus 2. So we have a minus 1 here. Okay, and then since we have the minus here, we can separate into 2. And this is the constant. We take out the constant. We left s plus 3 s plus 3 squared plus 2, and then minus with inverse 1 over s plus 3 squared plus 2. Alright. Now, this part is a shifting. Okay, first shift theorems. Okay, let me write here. Inverse Laplace transform of s plus 3 over s plus 3 squared plus 2, what we will obtain. Okay, if using the first shift terms, okay, numerator we have s plus 3, denominator also have s plus 3. Okay, and we use the first shift theorem, we obtain exponent negative 3t. Okay, and then inverse Laplace transform of, and the answer will be equal to s over s squared plus 2. Okay, bear in mind that we use the first shift theorems. If you want to use the first shift theorems, the numerator must be s plus 3, and denominator also s plus 3. That's why we get the exponent negative t. And then what we left is the s, okay, over s squared. Okay, square is still remain a square here, plus 2. Okay, this one is we use the first shift theorems. If we use the table of Laplace transform, for example, I give an example, like we have the s plus 3 squared plus 2, what we will obtain? This one is, we will obtain from here is the, using table of Laplace transform, we obtain the exponent negative 3t. Okay, and then inverse Laplace transform of 1 over s squared plus 2. Okay, so this one is we use the table of Laplace transform. So I hope you can differentiate, but both you will get the same answer. If you use the first shift, the numerator and denominator must be the same. If you use the table of Laplace transform, only 1 over s plus 3. If you still remember from the table of Laplace transform, exponent at equal to 1 over s minus a. Okay, I hope this explanation can clear your doubt. This part and this part. Okay, now we jump from here. So as I mentioned to you, you remain the 1 over 3, and then this one will get exponent negative 3t inverse s over s squared plus 2 minus this one. We obtain exponent negative 3t inverse 1 over s squared plus 2. Okay, next we obtain 1 over 3 exponent negative 3t inverse. Okay, I do it slowly, step by step. This one is the square root of 2. This one is to form the cos 80, okay, minus exponent negative 3t multiply with, okay, this one we multiply with, okay, let's say if you have this one, if you want to get a sine 80 is a s squared plus a square, right? So a square, now your a is 2, so we need to a square. How to get a square is square root and square. So this one is square root. So since we have the square root of 2, so this one we need to divide by square root of 2 to cancel out. So now you can obtain 1 over 3 exponent negative 3t. We change to the cos square root of 2t minus exponent negative 3t divided by square root of 2 sine square root of 2t.